Assalamualaikum and a very good day to everyone. My name is Syahmi Wafiy bin Muhamad Shariff, and today I would like to present my PSM title, which is Simulation and Modeling the Spray Behavior of Ammonia-Biodiesel Fuel Blends and Injector Characteristics in Microgas Turbine. So these are the content of my slide. There are research background, problem statement, objective, scope, literature review, methodology, and expected result. Research background. So alternative fuels to be used to reduce emission. So as we all know, the typical fuel that we are using now is emitting a lot of harmful emissions. So alternative fuels would be useful to reduce emissions. So injector system with specially designed combustion chamber to produce high efficiency combustion. So with the alternative fuel, the injector system design must be compatible with alternative fuel to reduce more emission. And that's why nozzle geometry of injector influence the alternative fuel's combustion and performance. So the spray that produced from the nozzles will affect the combustion performance as well. The problem statement. Inefficiencies in experimental method. So with experimental method, it requires a lot of heavy machinery and expensive tools to do the experiment, and as well as it consumes a lot of time. So next one is issues with ammonia low latent heat that cause poor atomization. So ammonia itself has very poor properties. So we must overcome this issue so that we will have more stable combustion performance. The next one is nozzle shape design produce cavitation and large droplets that affects combustion performance. So nozzle in this case will greatly affect the performance of the combustion. Objective. There are three main objectives of this study. So the first one is to study the simulation model for ammonia biodiesel in premix injector. And the second one is to simulate the spray characteristics of the premix injector nozzle. And thirdly is to analyze the effects of nozzle shape on spray characteristics of the premix injector. Scope. Four main scope for this study. The first one is nozzle shape, where we'll vary the nozzle shape. Second one is working liquid. The first one is the diesel and air fuel mixture, and the second one we will test with liquid ammonia. Third one is 45-degree angle injector angle with equivalent ratio of at 1. So this one is fixed. And fourth one is we will do the simulation by using ANSYS fluid and ANSYS workbench, where we'll observe the mass flow rate, flow velocity, spray pattern, spray droplets, and cavitation produced by the nozzles. Literature review. So, the first paper, Effects of Gaseous Ammonia Direct Injection on Performance Characteristics of Spark Ignition Engine. So basically the findings are about spark ignition engine by using ammonia fuel, where it increased the level of ammonia injected into combustion chamber result in both increased ammonia and increased NOx emission in the exhaust. So the advantage is by introducing ammonia into diesel fuel blend can act as alternative fuel without compromising engine power. And the disadvantage is as ammonia has low latent heat, therefore this is very unstable for the initial combustion. So the next paper is the influence of the diesel injector hole geometry on the flow conditions emerging from the nozzle. So the findings are basically the conical shaped nozzle reduces the mass flow rate in compared to conical shaped nozzles. So it compares the shapes of nozzles. And the advantage is the gas hole nozzle provide decent fluid dynamic efficiency such as the pressure velocity conversion that help to reduce the drawback effect of the connectivity. So KS hole nozzle is basically the inlet hole is slightly bigger. Third paper is the experimental study of the bioadditive fuel effects in biodiesel fuel on performance, emission, and combustion characteristics of diesel engine. So the findings is mixture of biodiesel with bioadditive promotes better fuel consumption, where it reduces NOx emission, in low engine speed but high in high engine speed. So the advantages are the addition of bioadditive really helps to provide more efficient fuel to more sustainable fuel. And the disadvantage is the increasing blend ratio cause weak fuel ignition and prolonged ignition delay. So the fourth paper is experimental study on the effect of the injector nozzle K factor on the spray characteristic in a constant volume chamber near nozzle spray initiation, the microscopy, and the droplet statistic. So the findings are different K factor nozzle have different impact on spray tip penetration. The greater the K factor, the higher the spray tip penetration. So advantage is the increase of nozzle K factor increases the number of small droplets, which can lead to better combustion performance. Disadvantage is a lack of study evidence where it states that nozzle K factor weakly affects the atomization characteristics. So it doesn't state why. It doesn't have a strong evidence of it. And the last one is effects of nozzle shape on the flow characteristics of premix injector using computational fluid dynamics (CFD). So the findings are formation of cavitation is significantly reduced when connectivity of nozzle increase from K factor 0 to K factor 2. So the advantage is there's a clear advantage of high K factor nozzle which helps in flow characteristics. So next is methodology. So from the start, we will start with literature review and we will define the parameters for CFD simulation where we identify the injector model and we will define the parameters in ANSYS software. So next one, we will construct the simulation model for premix injector using the diesel fuel where the model is from the injector model where we will set the boundary condition of the simulation. And from the boundary condition, we will do a validation using diesel fuel on premix injector to set as baseline to compare with other fuels and the varied nozzles. So all these are done in PSM1. So for note, the validation is only done 50% as I only done the flow characteristic and not yet to observe the spray pattern and the meshing of grid independent study. So next is to set up simulation for ammonia fuel on premix injector after the validation is done. And we will proceed with varied nozzle shapes, which the nozzle shapes we will explain later. And next, after the setup is complete, we will simulate it using ammonia fuel. And next is to analyze the data, which we will analyze whether the nozzle shape will affect the spray characteristic and the performance of the fuel until the end. And this is in PSM2. So these are the CFD simulation flowchart. So from the start, when we identify the geometry, we will insert it in the ANSYS software. And after that, we will perform meshing on the geometry. And then we will identify and set the boundary conditions into the geometry. And then we will select the suitable solver for the simulation, where in this case is the SST turbulence model. And next is the results where we can project it in image form, where we can see the patterns of the flow and the spray patterns. And next is grid independent study. We will compare the meshing size in order to find out more accurate results. And next is data analysis, where we'll transform it into graph forms. So simulation model. As mentioned earlier, diesel and air fuel mixture will be tested first as baseline by using 0 K factor nozzle. So when we set the baseline, we will compare it with the ammonia liquid fuel and we will compare it with other nozzle shapes, which in this case is the 1.3 and 2 K factor nozzle. So we will compare it whether the outcome is if the nozzle shape will affect the performance of the alternative fuel and whether it is good or not to replace it with the nozzle shape. These are the premix injector actual models. So we have the first picture, which is the actual premix injector. So the next one, we have the K factor 0 with 45-degree angle nozzle. And the next one is the injector swirler in the bottom of the injector. And next is nozzles with different diameter holes. And lastly, we have the disassembled nozzle. So in this study, I will use the CFD simulation by using ANSYS software. And here we can see the ANSYS workbench interface where we'll insert the premix injector geometry. And this is also where we will set the boundary conditions for the simulation. So the boundary conditions, so the first step is to identify where the air inlet is coming from. And the next one is where the fuel inlet is. And the next one is solid wall, where is the wall that are stationary for the premix injector. And the next is outlet, where the spray will spray on. And next is periodic wall, where it is set to be a dome shape, where it is limited so that the result is less error and more accurate. So the solver and after processing. So as mentioned earlier, the solver that is chosen for this simulation is the SST turbulence model, where it is very suitable to observe this kind of spray and flow pattern and characteristics. And the after processing is the grid independence test, where the meshing, we will split it more into meshes sizes, and we will compare the meshes sizes, which are coarse, medium, or fine mesh sizes, where the meshes size will be compared, and which one is more accurate, we will choose the mesh sizes. So the comparison of nozzle K factor 0, 1.3, and 2 for J4L. So these are the velocity contour for the three nozzle K factors. So it is expected that the ammonia fuel and the validation diesel air fuel mixture will also produce this kind of velocity contour, but in different velocity value. And the next one is the flow velocity of 1.0 millimeter nozzle diameter of Z4L. So this is just to show that the nozzles can produce this kind of flow velocity contour. And next one is a droplet spray at radial location of the nozzle. So as mentioned earlier, droplet also plays an important part in combustion performance. So when these nozzles are tested, we will also analyze the droplet spray characteristic, whether it is the sizes of the droplets and the probability of the droplets being spread. And next is the droplet size statistic of diameter out 0.2 millimeter nozzle. So these are the droplet size statistic we will spread out throughout the spray. So in conclusion, this expected result is whether the nozzles can influence greatly with the ammonia fuel, and whether the nozzle K factor 2, 1.3, or 0 will improve the combustion performance or the atomization performance of the ammonia fuel, and whether the nozzle shape can overcome the weakness of ammonia properties. And next is whether we can replace the ammonia fuel with the already existing diesel fuel and other biodiesels. So that's all for my presentation. Thank you for your time and attention.